So in the last session, so just we covered about data types, whatever there in Java. So now in this topic, so let me talk about next subtopic, literals. Keep subheading, literals, literals. Okay. So what is literal? Literals. Okay, here just observe. What is a literal? Suppose if I can take int x is equal to 10, I am taking. Int x is equal to 10. 10 I am taking. Sir, int, can you tell what is int? Int is data type. Correct or not? Int is a data type. Or we can use the term, it is a keyword. Int is a data type or keyword. Next, can you tell what is x? X is what? Name of variable. Name of variable. We can use the word identifier. We can use the word identifier. Next, what is a 10? Can you spell out what is a 10? 10 is a constant value which can be assigned to the variable x. X is a constant value. Okay, constant value which can be assigned to the variable. This constant value is nothing but literal. Are you getting? X is a constant value which is nothing but what? Literal. Okay, this is, observe this one. So what is int x is equal to 10? Okay, constant value which can be assigned to the variable is by default considered as a literal. Are you getting? Boolean literal, integral literal, floating point literals. Like what are various ways to specify literal value we can discuss. First, add literal. Any constant value, a constant value which can be assigned to the variable. A constant value which can be assigned to the variable. A constant value which can be assigned to the variable is called literal. A constant value which can be assigned to the variable is called a literal. Literal. Example. Get this one. Int x is equal to 10. Int x is equal to 10. Can you tell what is int? Data type or keyword. X is name of variable or identifier. 10 is a constant value or literal. 10 is a constant value or literal. So I hope it's a clear for you people, right? So what is a literal? Okay, for the integral data types, in how many ways we can specify literal value? For the integral data types, in how many ways we can specify literal value? Okay, this here. So first, which are integral data types? And what are integral types? Byte, short, int, long. These things are by default considered as what? Integral data types. Byte, short, int, long. These are integral types, right? For integral data types, in how many ways we can specify literal value? There are multiple ways are there. Sir, one way. Okay, here one way. Int x is equal to 10. One way, int x is equal to 10. Do you know? Here just we are specifying the value in decimal form. Are you getting, sir? 10, that's all, decimal. So we are specifying the value in decimal form. Are you getting? So this one is decimal literals. Are you getting, sir? We can specify value in decimal form. Base 10 is nothing but like our normal commonly used approach, right? Now the second one, we can specify value. We can specify value in octal form. Are you getting? Even in the octal also we can specify octal form. Octal form. Do you know this one is nothing but what? Base 8. If it is the octal, can you tell what are the allowed digits? 0 to 7. 0 to 7 is the allowed digits. Octal form 0 to 7. Now example, if we consider int x is equal to 10. Sir, here observe. If I can take int x is equal to 10, by default, JVM is always going to consider in decimal form. Decimal. Why JVM? Don't consider in decimal form. Can you please consider in octal? Can you please consider this value as octal? Octal. How we can specify is nothing but the number prefixed with the 0. If a number prefixed with 0, it is treated as what? Octal value, right? I hope you people can able to understand, right? Okay. So if a number prefixed with 0, it is treated as octal. Sir, have you observed? Don't feel, sir, it is octal. Octal means this is O like, not O. It is what? 0, 0. If a number prefixed with 0, it is treated as what? Octal, right? Best example, here just while learning numbers at our childhood, okay, at our school days, LKG or UKG like numbers, suppose I have a number is there, 20 is there, okay. If we add 0 at the end, this number will be multiplied by 10. 20, if I can add 0, 20 into 10 is 200. Now the value will become 200. If I can add one more 0, now the value will become what? 2000. 200 into 10, 2000. Sir, if we add 0 at the beginning, now there is no change in the value. Have you remembered? In the school days we learned, sir, at the beginning if we add 0, no change in the value. At the end if we add 0, now the number will be multiplied by 10. Sir, this rule not applicable for Java. If this 0 is not there, what is this one? Decimal value. If this 0 is there, what is a octal value which represent a different value? Octal 2000, decimal 2000, both are not same. There is a difference is there. Are you getting? Now int x is equal to 010 is nothing but octal. Next, we can specify literal value even in hexadecimal form also. Even in hexadecimal form also. Now we can use the term base 16. Now we can use the term base 16. Int x is equal to, sir, I am taking 10. Int x is equal to 10, 0x10. If a number prefixed with 0x, now this number is treated as what? Hexadecimal, right? Now here the allowed values is nothing but, base 16, 0 to 9, and A to F. Are you getting? 0 to 9, A to F. A means 10, B means 11, like is nothing but F means 15. 0 to 15 is nothing but allowed digits for base 16, right? Are you getting? But here one small doubt is there. Sir, A to F, is it lowercase or uppercase? Java is case sensitive programming language. Have you remembered in the last class I covered? Java itself is the case sensitive. Sir, can you tell A to F lowercase or uppercase? A to F lowercase or uppercase? Next, 0x. The number should be prefixed with what? 0x. Sir, this x is the lowercase or uppercase? X should be lowercase or uppercase? Or any case? Okay, make sure. Anyway, later we will discuss. As of now, keep that one as the suspense only. So total, in how many ways we can specify literal value for integral data types? Is nothing but what is the first way? Decimal. Second way, octal. Third one is nothing but hexadecimal. Decimal means base 10. Allowed digits are 0 to 9. Okay, octal means base 8, allowed digits are 0 to 7, the number should be prefixed with 0. Next, hexadecimal base 16, allowed digits are 0 to 9, A to F, allowed digits are 0 to 9, A to F, the number should be prefixed with 0x. Is it clear for all of you? Right? Okay, at this point. Yeah, done. For 1 minute, better to keep subheading integral laterals. For integral data types, how we can specify? Integral laterals. Integral laterals. Laterals. Integral laterals. Laterals. Okay. Within bracket, integral laterals. That's all. Add the theory. For integral data types. For integral data types. For integral data types. Data types. For integral data types, within bracket, byte short int long, byte short int long. For integral data types, byte short int long, we can specify literal value, we can specify literal value in the following ways. We can specify literal value in the following ways. We can specify literal value in the following ways. In the following ways. Okay, first one. Keep subheading. First one. Decimal literals. Decimal literals or decimal form. Any word you can use. Decimal form. Within bracket base 10. Decimal form within bracket base 10. Next, allowed digits are, and allowed digits are 0 to 9. Allowed digits are 0 to 9. 0 to 9. Example, int x is equal to 10. Example, int x is equal to 10. Decimal literals example, int x is equal to 10. Second one, octal form within bracket base 8. Octal form within bracket base 8. Octal form base 8. Okay, base 8. Next example, 1 minute. Base 8, allowed digits are 0 to 7. Allowed digits are 0 to 7. Next, literal value should be prefixed with 0. 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 Next, third one, example, int x is equal to 0, 1, 0. Int x is equal to 0, 1, 0. Next, third one, hexadecimal form. Hexadecimal form within bracket base 16. Hexadecimal form within bracket base 16. Example, 1 minute. Base 16. Okay, allowed digits are 0 to 9. Allowed digits are 0 to 9, comma A to F. Allowed digits are 0 to 9, comma A to F. But here one small thing you should aware. For extra digits is nothing but A to F. Can I use lowercase or uppercase? For extra digits, can I use lowercase or uppercase? Or can I use any case? Make sure Java is case sensitive programming language. That's why lowercase or uppercase. Okay, make sure, because I wrote lowercase only. Okay, so for extra digits we can use both the lowercase and uppercase. We can use both. Java is not case sensitive in very few areas. By default, Java is case sensitive language only. But in very few areas, Java is not case sensitive. This is one such place. Are you getting it? For extra digits within bracket 0 to 9. For extra digits within bracket 0 to 9. 0 to 9, 9. For extra digits within bracket 0 to 9. 0 to A to F. For extra digits within bracket A to F, within bracket A to F. We can use both the lowercase and uppercase characters. We can use both lowercase and uppercase characters. We can use both lowercase and uppercase characters. Both the lowercase and uppercase characters. Both the lowercase and uppercase characters. Okay, this is one of very few areas. This is one of very few areas. This is one of very few areas where Java is not case sensitive. This is one of very few areas where Java is not case sensitive. Java is not case sensitive. One of very few areas where Java is not case sensitive. Example, 1 minute. Java is not case sensitive. Next point. The literal value should be prefixed with. The literal value should be prefixed with. Literal value should be prefixed with. Literal value should be prefixed with. Should be prefixed with 0 small x or 0 capital X. So here also small x is allowed, capital X is allowed. 0 small x or 0 capital X. 0 capital X. Okay. Example. Int x is equal to 0x10. Int x is equal to 0x10. 0x10. That's all. Are you getting? So for integral data types, in how many ways we can specify literal value? Have you observed? Total how many ways are there? 3 ways. One is decimal, second one octal, third one is what? Hexadecimal, right? Okay, add. These are only possible ways. These are only possible ways to specify. These are only possible ways to specify literal value. These are only possible ways to specify literal value for integral data types. These are only possible ways to specify literal value for integral data types. For integral data types. For integral data types. That's all. Are you able to understand, right? Okay, this is one point what you people should be aware. Now, from this discussion, what possible questions we can expect for the exam? One possibility. Listen, sir, I am taking int x is equal to 10. Valid or not? Oi, int x is equal to 10. Int x is equal to 0786. Is it valid or not? Oi, int x is equal to 0786. Valid or invalid? Make sure compiler will give left and right. What is the reason? You know, if a number starts with 0, what it means? Octal. Octal means allowed digits are 0 to 7. How you can use 8? Immediately compile time error we are going to get saying integer number too large. Integer number too large is nothing but like compile time error we are going to get. Integer number too large. Next int x is equal to 0777. Valid or not? Int x is equal to 0777. Perfectly valid, no problem at all. Int x is equal to 0777. Itself is the valid combination only. Next int x is equal to 0x face I am taking. Valid or not? Int x is equal to 0x of face. Is it a valid combination or not? This one is valid because 0x means what? Hexadecimal. In the hexadecimal, FACE, valid combination, no problem at all. Int x is equal to 0x beef. Valid or not? Valid. Beef is nothing but in the A to F range only. What is the problem? Int x is equal to 0x beer. Invalid. Compile-time error by default we are going to get. Are you getting? Because R is not allowed. Are you getting? So maybe a chance to ask this type of questions, right? Make sure if the number starts with 0, octal, allowed digits are 0 to 7 only. Next, if the number prefixed with 0x, hexadecimal, allowed digits are 0 to 9 and A to F. Is nothing but A to F. Wherever R is there, that's why this one is nothing but invalid. Just observe. Let me show this one. Some people may feel so invalid, something like class test. Int x is equal to 10. I am taking. Int x is equal to 10 and SOP of x like this. Let me save this code as a tester.java. Okay. Here just observe javac tester.java. Is it valid or not? Javac tester.java valid. Okay, this is valid. Now Java test. You know what the output by default? 10 is the answer. Now my target is int x is equal to 0786. Valid or invalid? 0786 invalid. Integer number too large. Have you observed? Integer number too large. Like compile-time error we are getting. Next 00777. Valid or not? Valid. No problem at all. So 511 is the answer. Because 777 octal converted to decimal is nothing but like. Sir, 0x face. 0x face. Valid or not? 0x face. Yes, its value 64,000 some 206 or something like 64,206 like we are going to get. 0x beef some 48,000 something like. Yes, 48,879 like. Valid. 0x beer. Valid or invalid? Invalid. Semicolon expected like compile-time error we are getting. Are you getting? Semicolon expected like compile-time error, right? I hope you people can even take a bit style. Which of the following declarations are equal? Which of the following declarations are valid? Which of the following declarations are valid? Okay, take all these things. Take all. Right? So which of the following declarations are valid? So you people should have clear clarity, right? I hope is clear for you people. Okay, now the next possibility, make sure you people should have clear clarity about this terminology, right? Sir, I am taking int x is equal to, listen, very important, observe. Sir, I am taking class test, executable code only I am taking, even your knowledge is more enough to answer this one. public static void main string array args. Okay, public static void main string array int x is equal to 10, int x is equal to 10, int y is equal to 0 1 0, int x is equal to 10, int y is equal to 0 1 0, int z is equal to 0x10, int z is equal to 0x10, system dot out dot println x dot 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 y dot 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 z, like this I am taking SOP of x, y, z, like this. Sir, can you tell what is the output by default we are going to get? Okay, sir, here 10, but here 0 1 0, but here 0x10. Programmer having the choice to specify either in decimal or octal or hexadecimal. But while printing, JVM is always going to print in decimal form only. Remember this one. Sir, 10 decimal, that's why 10 only. Y is nothing but 0 1 0. Sir, octal value 10. Can you please convert into decimal? Okay. So 0 into 8 power 0 plus 1 into 8 power 1. 0 into 8 power 0 plus 1 into 8 power 1. What about its value? 8. Are you getting 8? That's why. So 8 dot dot dot. Next z is nothing but, can you please print z? So 0x 10 16. Can you please convert into decimal value? 10 is nothing but, can you please convert into decimal? 0 into 16 power 0 plus 1 into 16 power 1. What about its value? 16. Now like this. Are you getting? So 16 itself is the answer. 0 into 16 power 0. 0 into 1 0 plus 1 into 16 is nothing but 16, right? So here make sure you people should aware. Programmer having the choice to specify value either in decimal or octal or hexadecimal. But JVM is always going to provide the value in only decimal form, 10, 8, 16, like. Now let me cross check this one, whether my analysis is the correct or not. Int x is equal to, yeah, just observe this one. Int x is equal to 10. Int x is equal to 10. Int y is equal to 0 1 0. Int z is equal to 0x10, like this. Are you getting? SOP of x plus dot 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 plus y plus dot 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 plus z, like this I am taking. X, y, z, like this. Sir, now observe, the code compiles fine. What the answer by default we are going to get? 10, 8, 16 itself is the answer. Clear for all of it, okay? This is, so like take this example, example 2. Programmer having the choice to specify the value either in decimal, octal, hexadecimal, but JVM will always provide the value in only in the decimal form. So the output by default we are going to get 10, 8, 16. Completed, I hope. Okay, so now the third one. Okay, this is one option, another. So another possibility to ask the question. Next, legend this one. Sir, I have one integral lateral is there, 10 is there. R010 is there, R0x10 is there. So 10, 010 or 0x10. Do you know whether it is a decimal or octal or hexadecimal? Anything. By default, every integral literal, it may be decimal or octal or hexadecimal, is by default what type? Integer type. Are you getting? So every integral literal by default what type? Integer type. Sir, I want to specify explicitly it is the long type. Explicitly it is the long. How you can specify? If a number suffixed with small l or capital L, anything, either small l or capital L, 10L or 0x10L. Now this number by default considered as long type, right? Are you getting, sir? Can you please consider it is the long? How you can specify is nothing but by suffixed with small l or capital L. Sir, by default every integral literal is what type? Integer type. I don't want to specify it is the int, I want at the long. Then we should specify as explicitly suffixed with the L. Okay, at this point. By default, every integral literal, by default every integral literal is of integer type. By default every integral literal is of integer type. But we can specify explicitly, as a long type. But we can specify explicitly as a long type by suffixed with small l or capital L. By suffixed with small l or capital L. By suffixed with small l or capital L. Okay, like now observe this point. Sir, here I am taking int x is equal to 10. Valid or not? Valid. Because what is this one? Int value. Integral literal is of int type. Int value, int variable. No problem at all. Acceptable. Int x is equal to. Sir, I am taking here, just observe. Long L is equal to 10L. Valid or not? Long value, long variable, no problem at all. Int and long. Next, int x is equal to 10L. Valid or not? Invalid, because 10L means what? Long. Long means how many bytes? 8 bytes. Int is how many bytes? 4 bytes. Or how you can assign 8 byte value to 4 byte variable? Immediately, compile time error by default we are going to get saying, what is that error? Possible loss of precision found long required is nothing but what? Int. Because 8 byte value, how you can specify to the 4 byte int variable? Invalid. Sir, I am taking long L is equal to 10. Valid or not? Long L is equal to 10. Valid or not? Yes, boss. Because 10 is what type? Integer type. Int is how many bytes? 4 bytes. Long is how many bytes? 8 bytes. Sir, 8 byte variable, assigning 4 byte value, no problem at all. Itself is acceptable. Are you getting? Sir, by default, every integral literal is of what type? Integer type. But we can specify explicitly as long by suffixed with a small l or capital L. Take this one. Example. Int x is equal to 10. Long L is equal to 10L. Int x is equal to 10. Long L is equal to 10L. Next, int x is equal to 10L. Next, long L is equal to 10. Int x is equal to 10L. Long L is equal to 10. So we will get compile time error saying possible loss of precision found long required int. Like this compile time error we are going to get. Are you able to understand, right? Okay, this is long L is equal to 10 like. Any explanation is required? Okay. Next. Sir, by default every integral literal is what type? Int type. Sir, I want to specify explicitly as long type. How we can specify? By suffixed with a small l or capital L. Now my target is, sir, can you please consider, okay? Can you please consider this integral literal as byte type? Are you getting, boss? It's a byte value. It is a short value. How you can specify? Sir, if a number suffixed with b, it is treated as what? By. If a number suffixed with s, then it is treated as what? Short. Is there any such type of convention? If a number suffixed with b, byte, if a number suffixed with s, short type. Sir, 10b, 10s, Secunderabad, Kondapur bus number, I hope. Bus number only. Okay, is it possible? Okay, make sure it is not byte value, it is not short value. If you are taking like this, compiler is ready to give left and right. Then how you can specify? Very simple. So 10b, 10s, very, very simple. How you can specify is, so make sure you people should have clear clarity about this terminology. Right? There is no direct way to specify byte and short literals. Are you getting? There is no direct way to specify byte and short literals. Then how you can specify? Is nothing but very, very simple word. Sir, indirectly we can specify. What is the way? Whenever we are assigning integral literal, sir, I have an integral literal. Whenever we are assigning integral literal to the byte variable, whenever we are assigning integral literal to the byte variable, and if the value within the range of byte, yes boss, within the range of byte, then compiler automatically treats it as a byte literal. Are you getting? Compiler automatically treats it as byte literal, right? Byte b is equal to 10. Byte b is equal to 10. Okay, if we are assigning integral literal to the byte and the value within the range of byte, compiler automatically treats it as a byte literal. No problem at all, itself is the valid. Now short, same here, see, byte b is equal to 127. Sir, can you tell valid or not? Valid. Next, byte b is equal to 128. Valid or invalid? Sir, integral literal to the byte variable, but the value not in the range of byte. Immediately compile time error you are going to get, saying, can you spell out what that compile time error? Possible loss of precision found. Possible loss of precision found. Int. By default what type? Int. Required. Sir, required byte. Same rule by default applicable for short also. Okay, whenever we are assigning integral literal to the short variable, and if the value within the range of short, then compiler automatically treats it as a short value, right? Simple. Sir, short s is equal to 32,767. Valid or not? Integral literal assigned into short and the value within the range of short, valid. Short s is equal to 32,768. Valid or invalid? Invalid, because the value not in the range of short. Do you know what compile time error we will get? What is that error? Possible loss of precision. Possible loss of precision found. Int, by default int, required is nothing but what? Short. Found int required, short like compile time error, right? Do you know? Yesterday some people asked, sir, byte b is equal to 128. Possible loss of precision found int. Sir, why it is the int? It is actually short value, right? Found short like we have to get. Why compiler is getting found int? The reason is, by default every integral literal is of what type? Int type. That's why it is treated as found int in this case. Okay, add the theory first. There is no direct way to specify. Byte and short literals explicitly. There is no direct way to specify byte and short literals explicitly. There is no direct way to specify byte and short literals explicitly. Byte and short literals explicitly. There is no direct way to specify byte and short literals explicitly. But indirectly we can specify. But indirectly we can specify. Indirectly we can specify. Indirectly we can specify. Whenever we are assigning integral literal, whenever we are assigning integral literal to the byte variable, whenever we are assigning integral literal to the byte variable, and if the value within the range of byte, then compiler treats it automatically. Compiler treats it automatically as a byte literal. Similarly, short literal also. Okay, take this example. Byte b is equal to 10. Example. Byte b is equal to 127. Byte b is equal to 128. Compile time error, possible loss of precision found int required byte. Next, short s is equal to 32,767. Short s is equal to 32,768. Possible loss of precision found int required short. Possible loss of precision found int required short. Required short, like completed, I hope. Okay, so that's all. These are various things you have to remember about integral literals. Are you getting that? So few things. Sir, in how many ways we can specify literal value for integral types? 3 ways: decimal, octal, hexadecimal. Next, by default every integral literal is of what type? Int type. But how we can specify explicitly as a long type? By suffixed with a small l or capital L. But byte and short, there is no direct way. Clear for all of you, right? Okay, this is next. Keep submitting. Floating point literals. Floating point literals. Floating point literals. Floating point literals. Okay, now here just observe this one. So floating point literals. Okay, what is the point is? Observe. Sir, here I am taking, so which is the floating point literal? Floating point, decimal point, are you getting 123.456? This one is the floating point literal. Are you getting? Wherever decimal point is there, it is the floating point literal. Now I am taking, here observe. Sir, float f is equal to 123.456. Valid or not? Are valid or invalid? Valid or invalid? Ayo? If I can take like this, compiler will give left and right. Because 123.456 is of what type? Double. By default, every floating point literal is of double type. If it is the double means how many bytes, Anna? 8 bytes. But float is how many bytes? 4 bytes. How you can assign 8 byte value to the 4 byte? That's why immediately compile time error saying possible loss of precision, found double but required. Now found double but required is nothing but what? Required is a float. Is the compile time error right? Then how you can specify explicitly as float type? How we can specify explicitly as float type? Sir, float f is equal to 123.456 small f or capital F. Okay. If a number suffixed with small f or capital F, okay, now this number is by default treated as what? Float type. Sir, float. Now float, no problem at all, acceptable, right? Are you able to understand? Next, double D is equal to 123.456. Valid or not? Double value, double variable, no problem at all. So by default every floating point literal is of what type? Double type. We can't assign directly to the float variable, but we can specify floating point literal as a float type by suffixed with a small f or capital F, right? Okay, at this point. By default, every floating point literal, is of double type, and hence we can't assign directly to the float variable, okay, this is, are you getting? But next para, but we can specify floating point literal, but we can specify floating point literal as float type by suffixed with small f or capital F, okay. Take these examples. Float f is equal to 123.456. Possible loss of precision, found double required float. Float f is equal to 123.456 f. Valid. Double D is equal to 123.456. Double D. Completed, right? 123.456 like. Okay, that's all. Next up, sir, I'm taking one simple line. You have to tell whether it is valid or not. Okay, what's my line here is observe. Double D, double D is equal to 123.456 capital D. Double D is equal to 123.456 capital D. Because small f capital F means float, small d capital D means double. Small f or capital F means float, small d or capital D means double. Valid or not? Valid or invalid? 100% pakka. This one is okay. Make sure here just have a look once. Double D is equal to 1, 2, 3, 4, 5, 6, 7 also I am taking capital D and SOP of D. Are you getting? 100% pakka. No compile time error. Have you observed? Double D is equal to 1 to 3.4567 D. Okay. No compile time error, no runtime error. Happily 1 to 3.4567. Are you getting? So every floating point literal by default double type, but we can specify explicitly as double by suffixed with a small d or capital D. Of course, this convention is not required. What is the reason? You know why this convention is not required? Because by default is already double type, but still this convention is there. Okay, suppose if I can take float f is equal to 123.456 D. Sir, this one invalid because 123.456 D is what type? Double. How you can assign to the float? Now immediately compile time error we are going to get saying possible loss of precision, found double. Found double required is nothing but what? Found double required is a float like. Are you getting at this point? We can specify explicitly, floating point literal as a double type. We can specify explicitly floating point literal as a double type. Floating point literal as a double type, by suffixed with, as a double type by suffixed with small d or capital D. We can specify floating point literal as a double type by suffixed with small d or capital D. By suffixed with small d or capital D. Of course, this convention is not required. This convention is not required. Okay. Now take this example. Double D is equal to 123.456 D. Double D is equal to 123.456 D. Next, float f is equal to 123.456 small d or capital D. 123.456 small d or capital D like. So we are going to get compile time error saying possible loss of precision, found double required float. Possible loss of precision, found double required float. Okay. Now next one. Make sure next point. It is also one conclusion what we have right. Now the next terminology take a bit special care. This is about float by default what type like. Next I am taking here see double D is equal to 123.456 valid or not? Double D is equal to 123.456 valid. Double D is equal to 0123.456. 0123.456. Okay. Double D is equal to 0x123.456. Are you getting these three? Sir, I hope related to these not required to keep any explanation. Because first one by default what type? What is this one? Decimal. If a number prefixed with a 0, what is this one? Octal. If a number prefixed with a 0x, what is this one? Hexadecimal. Are you getting? Any explanation is required about this one? First one is what? Decimal. Second one is what? Octal. Third one is what? Hexadecimal, right? But make sure, very important, compiler is ready to give left and right. Okay. Floating point literals we can specify only in decimal form. Are you getting? Octal, hexadecimal, such type of terminology not applicable. By mistake, if you are trying to use integral literal convention here, compile time error you are going to get. Sir, first one perfectly valid. Second one perfectly valid. Third one invalid. Compile time error we are going to get saying malformed floating point literal. Malformed floating point literal is nothing but like comparative method we are going to get. Malformed floating point literal like. Sir, here the point is double D is equal to 0x123.456. You are telling malformed floating point literal comparative method, right? Now my question is, why second one is the valid? Because even though we added 0, it is treated as the decimal only. Sir, is it a decimal value or not? Yes. So it's not octal, treated as the decimal. But 0x, what is the meaning of 0x like? So is it a decimal literal or octal literal? It is decimal literal. It is a decimal literal, but not what? Octal literal. Sir, where is the proof for that? If you want, just observe this one. Sir, I am taking here legend. Double D is equal to 0.123.456. If it is really octal, then this octal value should be converted to decimal, and the equivalent decimal value I have to get. But I am telling it's not octal, it's the decimal only. That's why direct value by default we are going to get 123.456 only. Clear proof. It is not the octal, it is the decimal. Next 0x I am taking. If I can take 0x, immediately, have you observed? Compiler is ready to give left and right malformed floating point literal. Are you able to understand? Okay, this is comparative method, right? Sir, we can specify floating point literals only in the decimal. Octal and hexadecimal forms are not allowed. Okay, at this point, we can specify floating point literals. We can specify floating point literals, floating point literals only in. We can specify floating point literals only in decimal. We can specify floating point literals only in decimal, only in decimal form. And we can't specify in, and we can't specify in, and we can't specify in octal and hexadecimal forms. And we can't specify in octal and hexadecimal forms. And we can't specify in octal and hexadecimal forms. Octal and hexadecimal forms. Are you getting the point, right? Okay. So take this example now. Malformed floating point literal. This is the comparative method we are going to get. So floating point literals can be specified only in decimal. Octal and hexadecimal forms are not allowed. If you are trying to keep comparative method, we will get malformed floating point literals. Completed, right? Malformed floating point literal like. Okay. It is the decimal literal but not octal literal like. Okay. So based on this small conclusion, there may be a chance of asking the possibility like this. Sir, again observe, very very important here legend. Sir, I am taking double D is equal to 0786 double D is equal to 0x of face. Sir, first one valid or invalid? First one valid. Second one valid or invalid? Okay. So can you repeat once again? First one valid or invalid? First one valid. That's why it is invalid. Sir, second one, is it valid or invalid? Second one valid or invalid? invalid, that's why it is valid. Ayyo, reverse answers you are telling. Sir, first one valid or invalid? Invalid, because I kept already. Second one is valid or not valid? Why? Most of the people are going to feel, sir, first one is the valid, second one is invalid. No, reverse. What the reason for that is? Correct, your expected reason okay, but identify loophole. Sir, even though we are adding 0, it is treated as decimal but not octal. Ever remember decimal? That's why digit 8 is allowed. Okay, what is the problem, sir? Like you may have that doubt. Who told you it is floating point literal? When we say that a literal is the floating point literal, point 1, 2, 3 point should be there. Either any point? No. If a point is not there, by default it is treated as what? Integral. Integral literal starts with 0 means what? Octal. Octal means 8 is not allowed. Comparative method saying integer number too large. Like comparative method we will get. Sir, double D is equal to 0x face. Are you getting? Double D is equal to 0x face. Sir, is it integral literal or floating point? Integral literal. Integral literal starts with 0x means what? Hexadecimal. FAC is allowed. Sir, we can assign integral literal directly to floating point variable. Under that integral literal can be specified either in decimal or octal or hexadecimal, no problem at all. Best example, do you know, is it valid or not? You have to tell. Double D is equal to 10 SOP of D. Valid or not? Double D is equal to 10 SOP of D. Valid. What the answer by default we will get? 10.0. Sir, we provided which one? 10. Integral literal 10. Integral literal can be assigned to floating point variable, and so that integral literal automatically converted to float or double type. Okay, this is 10.0. Same here. Sir, integral literal we are trying to assign, but you are not specifying properly. Integral literal you are trying to assign. Do you know 0x face? So 64,206.0 is the value. I will print. Next up, double D is equal to 0786.0. 0786.0. Valid or not? Point is there. What is this one? Floating point literal. Floating point literal even though starts with 0, not octal, decimal only. Valid. Double D is equal to 0x face point 0. Valid or invalid? Invalid. Sir, floating point literal starts with 0x. What it means? Like comparative method we are going to get. Any explanation is required? Okay, this is now. Observe this point. Here, legend. Double D is equal to 0786. Valid or invalid? Invalid. Integer number too large. 0786.0. Valid or not? Valid. What is the answer by default we are going to get? 786.0. Similarly, double D is equal to 0x face. Valid or not? 0x face. Valid or not? Valid. 64,206.0. 0x face point 0. Valid or invalid? Invalid. Malformed floating point literal. I hope you people can aware. Sir, we can assign integral literal to the floating point variable. But that integral literal you can specify either in octal, hexadecimal, decimal form, no problem. Now, sir, can you tell is it valid or not? Double D 10. Valid. Double D is equal to 0777. 0777. Valid or not? Valid. Don't get confused. Okay, at this point. We can assign integral literal. We can assign integral literal directly to. We can assign integral literal directly to floating point variables. We can assign integral literal directly to floating point variables. And that integral literal under that integral lateral, under that integral lateral, under that integral lateral can be specified, can be specified, under that integral lateral can be specified either in, can be specified either in decimal or octal or hexadecimal forms. Under that integral lateral can be specified either in decimal or octal or hexadecimal forms, either in decimal or octal or hexadecimal forms, decimal or octal or hexadecimal forms. Okay, take all these examples and make sure you people should aware. Take all. Double T is equal to 0786. Double D is equal to 0x of phase. Double D is equal to 0786.0. Next 0x phase 0.0. Next double D is equal to 10. Double D is equal to 0777. Completed, I hope. Is it clear for all of you, right? Okay. Next one. Here say, sir, can you tell is it valid or invalid? If I can take like this, okay, if I can take like this one, valid or not? Double D is equal to 1 minute. Double D is equal to 10, valid. Just now we covered. Int x is equal to 10.0, valid or not? Invalid. Because integral lateral we can assign to floating point variable, but floating point lateral we can't assign to integral types. Do you know what comparative method we will get? Possible loss of precision, found double, required is nothing but what? Required int. Is the comparative method, right? Found double, required is int. Okay, at this point. We can't assign floating point laterals to integral types. We can't assign floating point laterals to integral types. We can't assign floating point laterals to integral types. Integral types. Add double D is equal to 10. Double D is equal to 10. Int x is equal to 10.0. Double D is equal to 10. Int x is equal to 10.0. Possible loss of precision, found double but required int. Found double, required int. Completed, right? Okay. Next, last point about floating point laterals. Sir, can you tell is it valid or not? You have to decide. Okay, here saying double D is equal to 1.2 E3. Double D is equal to 1.2 E3 SOP of D. 1.2 E3 SOP of D. So is it valid or not? Okay. Do you know this notation is called exponential form, or some people may use scientific notation, right? Sir, 1.2 E3, what it means, Anna? 1.2 E3 is nothing but 1.2 into 10 cube. 1.2 into 1000. 1.2 into 1000. So 1200.0. Regarding SOP of D, what answer by default we are going to get? 1200.0. Sir, make sure we can specify floating point literal even in exponential form. If we specify in exponential form, what will happen is nothing but what is the, how it is going to be evaluated is like this. Okay, now let me cross check, is it valid or not? Double D is equal to 1.2 E3. 1.2 E3, double D is equal to 1.2 E3 SOP of D. Okay, have a look once. Now see this point well. Okay, so 1200.0. I hope is clear for you, right? Sir, can you tell float F is equal to, up to this it is the value. Float F is equal to 1.2 E3 SOP of F. Is it valid or not? Valid or invalid? Invalid. Because 1.2 E3 by default treated as what? Double. Because every floating point literal is of double type. How you can assign to float? Possible loss of precision. Found float is nothing but required float found double like comparative method, right? Now I have to take small f or capital F. If I can take answer with a small f or capital F, valid or not? Valid. No problem at all. 1200.0. Is it clear? Now here let me show. 1200.0 is nothing but like, sir, okay, itself is nothing but valid. Now float F is equal to 1.2 E3. Valid or invalid? Invalid. What comparative method? Possible loss of precision. Found double, but required is nothing but what? Float. Required is the float. Next, float F is equal to 1.2 E3 F. Float F is equal to 1.2 E3 F. Is it valid or invalid? This one is nothing but perfectly valid, right? I hope is clear. So at this point, we can specify floating point literal. We can specify floating point literal. Even in, we can specify floating point literal even in exponential form. Even in exponential form, within bracket, scientific notation, within bracket, scientific notation, exponential form, scientific notation. Okay, so take this one example. Double D is equal to 1.2 E3 value SOP of D 1200.0. Next, float F is equal to 1.2 E3. Comparative method, possible loss of precision. Found double, required float. Next, float F is equal to 1.2 E3F. Completed, right? 1.2 E3F. Okay, like comparative method we are going to. So this one is the value like this. So that's all. These are the loopholes what you people should aware related to what? Floating point literals, right? Next, can I complete it, right? Next one, keep supporting Boolean literals. Boolean literals. Do you know? So for the Boolean data type, can you tell what are the allowed values? This part we covered already in the Boolean data type. So exactly same things only we are going to discuss. Sir, only allowed values for Boolean data type are true or false. Correct or not? Only allowed values for Boolean are true or false. Add the only allowed values. The only allowed values for Boolean data type are true or false. True or false. True or false. False. Okay. True or false. That's all. Now do you know, in the last class also I explained this point. Double D is equal to, sorry, here let me take Boolean. Boolean B is equal to, okay, true I am taking. Valid or not? Boolean B is equal to true, valid. Boolean B is equal to, 0 I am taking. 0. Boolean B is equal to true. Boolean B is equal to true I am taking. Can you tell second one, valid or invalid? Invalid. Do you know? 0 means false, 1 means true. Such type of convention not applicable for Java. Do you know? Can you spell out what compile time error? Incompatible types. Incompatible types found. Which one is the found? Int. Found int. Required is what? Boolean. Is nothing but like compile time error, right? Next, Boolean B is equal to true. Valid or invalid? Invalid. Boolean B is equal to true. Invalid. Because it is not a valid value for any type. That's why what compile time error? Cannot find the symbol. Cannot find symbol. Which is symbol? Is nothing but variable true. Cannot find symbol, variable true. In which location? Class test. In which location? Class test. Like, sir, Boolean B is equal to true. Valid or invalid? Boolean B is equal to true. True. Valid or invalid? Invalid, because it's a string. How you can assign to the Boolean? Compile time error saying incompatible types. Incompatible types found. Found which one? So java.lang.string required. Required what? Boolean. Is the compile time error we will get. I hope take all these things. Boolean literals. The only allowed values for the Boolean type are true or false. If we provide any other, immediately compile time error we are going to get. Take clearly, we covered already. These are things while covering Boolean data type. Boolean B is equal to true, valid. 0 means invalid, true, like. Incompatible types found int required Boolean. Completed, I hope. Clear, right? Boolean B is equal to true. 0 invalid, capital true. Completed, I hope. Okay. Next one. Next up. Just here, observe this one. Sir, I am taking Boolean. Here just take special care. This part also we covered already. Int x is equal to 0. Int x is equal to 0. If of x system.out.println of hello, else system.out.println of hi. Valid or invalid? Invalid. Int x is equal to 0 if of x. Hello, else hi. What is the answer? Here compiler is ready to give left and right. You know, if he is always expecting what? Boolean. But in the place of boolean, what thing we are providing? Int. That's why comparative method saying possible loss of precision. Sorry. What is this one? Incompatible types. Not possible loss. There is no compatibility, right? Incompatible types. Incompatible types found what? Int required boolean. We covered while covering boolean data type these. Found int required boolean. Same here, see, while of one system dot out dot println of hello, while of one SOP of hello. Can you tell, is it valid or invalid? This one is invalid because while is always expecting what? Boolean. But instead of boolean we provided int. That's why is nothing but invalid. Do you know? In C language both are valid. In the C language hello will be printed how many times? Infinite number of times, because one is the true, while of true keep on, and here 0 means false. If of false mean high is going to print. In C valid, but in Java both are invalid, right? Okay, take these examples also. And x is equal to 0 if of x SOP of hello, else SOP of high. Comparative method saying incompatible types found int required boolean, like. While of one SOP of hello. Incompatible types found int required boolean. Completed, I hope. Can I? That's all. This is about boolean literals. Now keep submitting. Completed, right? Next, char literals. Char literals. Char literals.